Okay. So we got that. And we pull up our handy dandy email. And let's do conversation by subject. And maybe that'll be a little bit, let's see, that's R4, R3, 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 R4. That's 102. That's not pertinent to what. Let's delete all those. Let's see what happens to Mr. Whose name did I call a while ago? Yeah, his. Good God. Well, let me just do Holly first. Oops. Okay. My email is messed up. So I'll just have to go by date. I could do from, just go down, there. What class is that? Okay, that's 102. All right, we'll just start from here. All right, when I do a question that's sent to me, I usually give y'all the section and number and all that. Now this comes from the review section, which is the whatever section you want to call it, the assessment 102 review or whatever, but it's review 4.39 and it comes out of number 25 online. All right, so it's number 25 on your online homework, and we will look at it. I don't know why it does that. I have to go down here and pull it up. And there is the question. Go ahead and write it down. Number 25 on the online homework from 102. I meant from 102 review. And while y'all are writing it down and working it, I'll recite it to you because, well, let me do this first. And then I'll recite it to you. No sneezing in class. We've already started class. No sneezing or coughing or hiccuping or yawning. I have to tell you out of class. All right. A to the negative fifth, A to the over B to the negative third, raised to the negative third power. Now, there's several things you can do here. First of all, let's go over the handy-dandy rules. The first rule is called the product rule. And yes, you need to know what to call them. You just don't want to call it, that's where you take them exponents and do this and do that. Then you sound all crazy. A to the n times A to the m is equal to A to the n plus m. When you have bases that are the same, take your handy dandy highlighter. When the bases are the same and you are multiplying them, what can you do to the exponents? Add them. So x to the second times x to the fifth is x to the seventh. All right, that's your first rule that you should remember. The second rule is the conjugate to the product rule, which is the quotient rule. And the quotient rule says a to the n over a to the m is equal to a to the n minus m. Take your highlighter. If you have bases and you are dividing them, then what can you do with the exponents? Subtract them. The third rule is called the power rule. The power rule says that if you have a exponent raised to another exponent, you can do what with the exponents? Multiply them. The inverse rule. The inverse rule says that if you have a negative exponent, you flip it, 1 over a to the negative n is equal to a to the n over 1, or a to the negative n over 1 is equal to 1 over a to the n. In other words, what do you not want in a solution? You don't want a negative exponent. Only in scientific notation are you allowed a negative exponent. Now, some cultures don't care if you have a negative exponent. So you always need to be wary of that, because there'll be some teachers that ain't from around here that will say, what's wrong with a negative exponent? Okay, so, but most people do not want a negative exponent, so that's why you have this rule. And then the fifth rule is called the inverse power rule. And the inverse power rule is a rule that basically says you can flip everything that's in the parentheses and it'll change the exterior exponent. Okay? So, I'm going to, I can't go, I don't think I can, let's see if I can do that. It should let me go up here. No. Alright, then we'll do this. We'll take this, we'll take that, and we will copy, and we will just do this, and go here, and copy, and go to the next page, and then we'll right click, and we'll put in the word. There we go. Y'all ready for this? Alright, there's your inverse power rule. And the inverse power rule basically says if you have a to the n over a to the m raised to the negative w power, you don't focus on these guys. You focus on this guy because it's a negative exponent. So if you flip what's on the inside of the parentheses, you can change that to this. Now, a lot of people say, well, Hubert, I thought you said if you flip what's on, if you flip 1 over a to the negative n, it becomes the opposite. Yes, that's to the first power. But this is not to the first power. This is to a power greater than 1, or different than 1, not equal to 1. How about that? So this is used when you have an exponent not equal to 1. Because if you have an exponent equal to 1, then it's just, well, then you don't need the parentheses. So it would just be a to the n over a to the m raised to the first power, which they're going to use for the parentheses. So you don't have the parentheses, so you have a to the n over a to the m. And then if you flip them, it would be a to the negative m over a to the negative n. But why would you flip something? If it ain't broke, don't fix it. And the main thing you need to realize here is the difference between number 4 and number 5 is that you have a term raised to a power. In the previous problem, in the previous rule, you don't have a term raised to a power. You just have a term. So you have a cat here, or a cat here, and a tiger on the next page. They both have 4 paws, 4 legs, a tail. They both purr. They both meow in a different way. But one weighs 10, 12 pounds. The other one weighs 300, 400 pounds. Okay? Different. And there is a 6th rule I like to add, and that's the rational exponent, huh?
Okay.
What?
If n is negative but n is not,
It will stay the same.
oh, you would still.
It stays the same inside the parentheses. If they don't have parentheses, then it switches. That's the difference between the two. So if you have,
But if it's in parentheses and n, like I said, n's negative, but n's not, would you just put n on the bottom with the n?
you could, yeah, you could, but you still got to distribute this.
Yeah.
I mean, when you get through, you still got to distribute it. But if you don't flip both of them, this does not turn positive. You got to flip both of them. If you have x to the negative 5th over x squared raised to the negative 4, you could bring this down here and get 1 over x to the 7th, but it would still be raised to the what? It would still be raised to the negative 4. So you can either flip these or you can flip these. If you flip these, you get x to the 2nd over x to the negative 5th raised to the 4th power. If you flip these, you get x to the 7th over 1 raised to the 4th power. Either way, you're going to get the same answer. And that's the good thing about the rules of exponents. You're going to get the same answer no matter what, if you do everything correctly. And let's do that. All right? You can bring this upstairs. If you bring this upstairs, it's x to the what? And what's x to the 7th to the 4th power? X to the 28. What's x to the 7th to the 4th power? X to the 28. So you get the same answer no matter how you do it, as long as you do it legally. And the 6th one, I kind of add, it's a rational exponent rule. And it's good for you to see it because most of you are heading towards some form of a calculus. And radicals and calculus do not mix. And if you haven't made for calculus, you're going to hear that over and over and over and over and over. So rational exponents, get rid of the radical. And all you got to remember is the square root of x is equal to x to the 1/2. And I will take a, well, let me erase that 1/2. And I'm going to put a red 2 right here because that's for the index. And a blue 1 right here. And that's the exponent. So your rule basically is exponent over what? Index. You need to write that down. Exponent over index. And if it's not there, it's assumed to be a 2. If something else is there, then it's the 3rd root or 4th root or 5th root or whatever the case may be. Now, we've just covered all the rules in 102. Now let's go back to the problem. Now that we've gone to the cobbling please. Now work the problem. Can you work it several different ways? Can you start it several different ways? Yes. You start it however you want to do. There's somebody sitting there, you don't see it? I see if you can see it right there. Somebody's sitting there, his friend. They can see him sitting on top of him. I just don't understand these people that can't see in the 4th dimension.
Oh, they come on like you look 4 times faster than you can see them.
No, actually, there's a highway running through here in the 4th dimension. And there's a lake out there in the 4th dimension. You want to see it? can you distribute the -3? Is that legal? Yes. Can you flip the internal terms and get a +3? Is that legal? Yes. You can do several things. You can go ahead and do the product rule or the quotient rule inside the parentheses, and then you can do 3 or 4 different things. There's not a wrong way to start this problem, unless you just quit. And that's the best thing to do. That's the easiest thing to do. 3 pencil down. And you got to make that popping noise. You know, when you throw it down. Popping noise. No, more like. Yeah, there you go. Pencil makes a better pop though. This thing don't make a good pop. And kick the cat. Turn the desk over. Shout at your mother. Fluoride and acid. Real good combination. Do y'all like talk when y'all go home or what? Or y'all just sit in a dark room and not say a word? Yes, sir. How do you do it with what?
The rules, they're both A's, but down here, letters are different.
Okay, so you can, okay, I didn't even catch that. I thought they were both A's. I didn't even see that. They are different. So you cannot use the product rule and the quotient rule. So the only thing you can use here is the inverse power rule. You can use the power rule, and you can use the inverse rule, however you want to. But you can't use the quotient rule. You're right. Thank you. I thought it was both A's. All right, so let's go ahead and do that. One option. You could distribute using the power rule. So we're going to put power rule. And that's going to be A. What's -3 times -5? +15. And then B to the what? B to the 9. And that's your answer there. Now you could use the inverse rule. Inverse power rule. Inverse power rule says if you flip what's in the middle, which would be B to the -3rd over A to the -5th, that will give you to the what power? To the 3rd power. And then what's 3 times -3? B to the -9th over A to the what? Now, you don't have it, it's raised to the 1st power now, so you can flip it, and when you flip it, it becomes A to the 15th over what? B to the 9th. We get the same answer?
Okay, I did not get the same answer.
That's because you need to quit.
I know. But, okay, I flipped B and A, so B's on top, and A's on bottom, and I got a positive.
No, you get a +3. Okay, what are these?
But when I flip them, they're positive.
No. The only time, okay, this, B to the negative, oh, hold on. A to the -5th over B to the -3rd. Now, if you flip that, it's going to be the opposite, because this is to the what power? 1st power. Highlight that first. That first, if something is raised to the 1st power, do these parentheses need to be here? No. So you take your handy dandy marker and erase those, and that causes you not to need these. And then you would get, and I'll go through the proof in this in just a minute. And that'll be just A to the -5th over B to the -3rd, and then you just flip them, and you get B to the 3rd over A to the 5th. And that is fine. Sorry about that. Y'all supposed to have a fit. Okay.
That's
I know, I'm sorry. Where's that sign? Oh, somebody took it down. Wonder who. Sorry about that. There we go. All right. Let me show you. Start with something simple. A to the second over A, not A, B. Let's make that negative 2. B to the negative 2. All right, and let's raise it to the first power. All right, let's do our, since it's in a set of parentheses, let's ignore the fact that this is a 1 and you really don't need these parentheses. Let's go ahead and actually do the flip it on the inside and change that to a negative 1. So B to the negative 5th over A to the negative 2. And what does that change that positive 1 to? A negative 1. And what does that do now? Use your product rule. B to the 5th over what?
When you actually flip it, you actually do not change.
When it's in parentheses, you don't change it. That's the difference between the inverse rule and the inverse power rule. The inverse power rule usually has a exponent on the outside that's not equal to 1. Now let's do it this way. A to the negative 2 over B to the 5th. All right. It's got a, there's the 1, and there's our dotted in. We don't need those because the first power, you don't need these. So you really have A to the negative 2 over B to the negative 5th. Now, if you only have the power of 1, which means it doesn't have, what do? Use the inverse rule, and then you get B to the 5th over what? Look over here. Works both ways. You just pick which one you want to use. You can use the inverse power rule all the time and just make sure you change the positive 1 to a negative 1. Or you can make the difference between the two and just use the inverse power rule with the exponent being not equal to 1. And use this one when the exponent is equal to 1. So, capiche? Let's do another one. I guess means, I really don't understand it. Let's check the answer here. I don't know what we came out with, but y'all have it in your notes. So we'll just put an answer in there and then hit 3 times. That's the answer. I don't care what you say. You're a loser. Get a job. Quit school. What did I get? What did I get when we did the problem? Yeah, just come on in whenever you want to. That's fine. We've been here since 9:35. I'm sorry, I had to turn my phone off because it started blaring out all kinds of stuff.
Okay, so on that one, you just distribute the exponent.
Or you can flip what's inside and make it positive and distribute it. Doesn't matter. You can do either one.
But on that one, you just, the A is still on top of B is still on bottom.
And that either way. Here they just distributed. But there's nothing wrong with you making this positive. And a lot of people say, well, that's just extra work. I'm trying to show you how to use the methods. I'm not trying to show you how to use the quickest method. I'm trying to show you how to use the methods. Let's do a nerd. All right, try that one. And do it both ways. Do it with the power rule and then do it with the inverse power rule. And see if you come up with the same answer. For those of you that just joined us, we're working on problem sent to the instructor. Okay, I got your text. I texted you back.
I'll let you know when I got it. Thanks.
Just figure you need a compliment this morning. Losers show up late. Yep, every day, like I do. Okay? Don't take 3-4 hours to do it. So X, using the power rule first. X to the what? 25th over Y to the what? Now if you use the inverse power rule, that's going to be y to the second over, y to the negative 2 over x to the negative fifth raised to the negative fifth, to the positive fifth, sorry. And what's 5 times negative 2? And what's 5 times negative 5? Now, what is this raised to now? Now that you distributed the 5 to the first power. So now you can just flip them and you get what? X to the 25th over, and is that what you got over here? Now the first thing the LAD student's going to say is, well, I don't like the inverse power rule, that makes too much sense. Well, you're missing the whole freaking train, alright? You're an LAD. You're going to miss the train because that's all you're thinking about. The person that's not thinking that is thinking, so it doesn't matter which way you do it, you still get the same answer. And that's the whole point. There's different setups and different tools for different things. If you have a screw, like I showed you before, and it's a 3-inch screw, lag screw is what you call them, put boards into posts with. You don't sit there and take a sledgehammer and beat the screw into the post and board. Because if you do that, the threads, which make the hole bigger than the screw, will have no threads in the wood, so therefore you just take your hand and hit it and it'll just come off. There's tools for everything. There are certain tools that you use there's certain problems that you use this for, and there's certain problems that you use this for. This is a flathead screwdriver, this is a Phillips head. Okay?
I guess I thought like, if you just looked at it and made everything all that.
That's true when there's not parentheses around it. And let's check our answer. 3. You love to program these things in here. Sorry, that's not correct. No. You are a loser. You suck. Quit school. McDonald's is hiring. X to the 25th over Y to the 10th. And that's what we got both ways. So you feel better on that one? All right, let's do another. Let's do another question sent in. Doesn't log this out. You know, as more and more teachers use technology in their classroom, they wouldn't set the log out for teachers to be so quick. But since we only have 5 teachers on campus that actually use computers in their classroom. Anyway, I'm sorry. Okay, now I got to go back through the whole deal of finding my, where did my 110 go? Okay, well that's good. Thank you. All right. Let's go to date again. Well, where did yours go? There they are. Did we just do that one? That was 39. Okay, let me delete that one so we don't go back over it 15 times. All right, this one's 63, R3. This is the review section 3 in your book. R3, question 20. All right, this is called a complex rational expression. Now, the first thing I'm going to tell you to do on this one is make everything into a fraction. Make that 7 into a fraction. I'll start you off. 7 over 1 plus 1 over m over 7 over 1 minus 1 over n. Now, if you had me in algebra before, you know that the first thing I'm going to tell you to do whenever you have fractions is to what? Anybody? Clear them. Clear them. Especially with algebra. Clear them. So that means multiplying by the common denominator. Multiply through by the common denominator. So go ahead and do that. 3/4 of the class is sitting there going, I don't know what to do. I'll just sit here and meditate. So what's the common denominator? M. So what do? Well, first you get your red marker and you multiply by M over 1 over M over 1. What's M over 1 over M over 1? So how did you get to M over 1? Well, what's the common denominator of 1m and 1m? What's the common denominator? M. So m over 1 over m over 1. If it was x squared or m squared over 1, m squared over 1. If you had an m squared here and an m third here and an m fourth here and an m third here, when you get to the common denominator, you always go with the highest what? Exponent. So it'd be m to the 4th over 1 over m to the 4th over 1. Now we're gonna put a baby step in here. Well, some of y'all are going, I've never seen that before. Well, you'll be all right. M over 1, M over 1, M over 1, M over 1. Here's your baby step. Now, turn your markers back to black. 7 over 1, that whole song. 7 over 1, 1 over M, sorry. 1 over M. Dang old 7 over 1. Dang old 1 over M. Alright, finish it. Now, 80% of you should be able to finish it. 20% still on. Now, when you put that baby step in there, it just makes life a whole lot easier, doesn't it? Because what happens to the M's right there? And the M's cancel here. You got 7 times M and 7 times M. So, when you get finished, you're going to have 7M plus 1. Over 7M what? And you're done. Huh? No. Can't cancel them out because these guys are married. And these guys are married. And if they're married, they can't. They can't. There you go. Nice way of putting it, okay? Now, how can you get the how can you get them canceled? You can get them by factoring out a 7. Now, some of you close your eyes because it's going to cause a fraction. 7. That'd be M plus 1/7 over 7 times M minus 1/7. But what do you do when you factor? What do you do when you factor? Tell me what operation. There's only 4. Addition, subtraction, multiplication, and division. When you factor out a common term, what do you do? Divide. So, what's 7M divided by 7? What's 1 divided by 7? What's 7 divided by 7? M. What's our 7M divided by 7? And then 1. So, if you wanted to cancel out the 7s, that's how you would do it. So, this is a final answer, but this is probably what they want. So, let's see. I'll take either answer. Seven M plus 1 over 7M minus 1. All right, you try that one. That'll be 2 for the books. What's the common denominator? X. So 6 over 1 plus 7 over x over 6 over 1 minus 7 over x. Multiply through by the common denominator, which is x. So I'm not just going to multiply by x over x. I'm going to make a fraction out of that. And that way you won't get confused. So x over 1, x over 1, x over 1, x over 1, and then multiply through by your equation. 6 over 1 plus 7 over x. 6 over 1 minus 7 over x. Sorry. And what happens to the x's? They cancel. This turns into 6x. This turns into 6x. So your final answer is 6x plus 7, right? Over 6x minus 7. And if you wanted to factor it out, 6, x plus 7, 6, x minus 7, 6. So that's your answer, or that's your answer, but more than likely it's going to be this right now. And you see, now there's 3 type people in there. There's the person that's lost, and that baby step in red helps you. There's the person that remembers it, but a little bit slowly. They don't quite need the baby step because they know that 6 times x over 1 is 6 times x. And they know that 7x over x is 7. So they're doing it in their head because they remember doing it. And then there's a third person that already knows how to do it. We're not going to talk about the NASA engineers because the NASA engineers, they designed this 2,000 years ago. Okay? So we're not going to talk about them. You seen any NASA engineers in your other classes? Not yet. You will. Especially if they read. Then they really get smart after they read a couple of articles. And their answer is 6x plus 7, 6x minus 7, which is this right here. Capiche? Do you understand? Yeah, Hubert. Can we go to the next one? Yeah, sure. We'll be glad to go to the next one. Appreciate your interaction. 51/19. Now, what's the difference in this one and the one we just did? Dang old word right there. What's that word? That means we're what? Adding. We're not dividing. We're adding. So that means you just might as well go ahead and quit. Because that means you got to get a what? Common denominator. And that calculator can't do that for you, so you just quit.
It would simplify the x minus 6.
Hmm?
You could simplify the x minus 6, x minus 6.
Mm-mm. If it was division,
Okay.
yeah, or multiplication, it would be nice, but. And a lot of people say, well, that looks like a division to me. Well, division and sum don't go together. That's like oil and water. I'm sorry, OIL and water. Oil and water. Those people that pronounce it perfectly. I would like a quart of oil, please. We're going to use the oil method. give y'all a few minutes to try it. Half of you will try it, half of you will quit. And the half of you would try it, maybe half of you then might get it right, and the other half may not get it right.
When you find a common denominator, will it eventually cancel out and you won't have?
It might,
denominator?
it might, I don't know. I haven't done the problem yet. But before I do this problem, we're gonna go back to pre-algebra. No, not pre-algebra, probably basic math. One half plus 2/3. Remember doing these problems? And your teacher told you to do it on the calculator because they didn't know how to teach you either way?
I'm sorry, I shouldn't do that.
What do you gotta have? You gotta have a common denominator. If the denominators have nothing in common, nothing, like prime numbers, then you just what? Multiply them together. Now, I do it a little bit unorthodox because I'm trying to show you a point. So I just put these two together. Now, after you get the common denominator, you got to convert the what? Numerator. So 2 will go into 2 times 3. How many times? 3 times 1 is 3. 3 will go into 2 times 3. How many times? 2 times 2 is 4. And you get 3/6 plus 4/6 is equal to what? 7/6. Okay, that's one way people learn to do it. Another way is the big Z. 1/2 plus 2/3. And 2 times 3, 2 times 3. 2 will go into 2 times 3. 3 times. 3 times 1 is 3. 3 will go in there. How many times? 2 times 2. 3 plus 4. And 2 times 3 is 6. So all of us went through pre-algebra or whatever math, and we learned how to convert the numerators. Now, if you had a teacher that beat this in your head and beat this in your head and told you not to use a calculator, the chances are you don't have a problem right now. But if you had a teacher that told you, all that's extra work and I really don't like to do it, so you'll just do it with a calculator, then you're probably having problems right now. Because you can't do what I just put on the board a while ago if you can't do this. Or if you're very rusty with it. So then you moved on to algebra. And you had one of these. Again, you have 2 denominators that have absolutely what? Nothing in common. So what do? You just put them together. And when you find the common denominator, what's the next step? Converting to what? X will go into xy how many times? Y times 1 is y. Y will go into xy how many times? X times 2 is, so your answer is 2x plus y over xy. Why can't I cancel? Because these two are what? Married. And you could factor out 2 or That, the only thing you factor out is 2, but that's not gonna help you because there's nothing down here that will cancel with 2. So then you moved on to algebra 1. Well, let's do one more now, do pre-algebra. 1 over x plus 3 over x squared. Now these do have something in common. What is it? X. So if you have exponents and the base is the same, the common denominator will always be your highest exponent. Write that down, because some of you don't know that. So what's the common denominator of x and x squared? X squared. Now, I'm not going to write it like that because I want some of y'all to think. So instead of x squared, I'm going to write it x times what? X. How many times will x go into x times x? Nope. Nope. X times. Mark that out. How many times? X times. X times 1 is x. How many times will x times x go into x times x? 1. 1 times 3 is 3. So your answer is x plus 3 over x squared. Now, you've heard a few people say 1 and 2 and 3. That's where you got to be careful, because that'll get you. X goes into x squared x times. Not 2. 2 times x is 2x. 1 times x is 1x. X will go into x squared x times. X times 1 is x. X times x will go into x times x 1 time. 1 times 3 is 3. Somebody said x times. X squared will go into x times x. X times, that would be x to the what? Third. And there's no x to the third in the problem. So x squared will go into x squared 1 time. 1 times 3 is 3. And then you moved up to algebra 1. And when you moved up to algebra 1, you got something like this. Do they have anything in common? Careful. Most people would say, yeah, they got x in common. No, these two are married. X plus 2 and x minus 4. They're married. So really, they have nothing in common. Now, if it was x and x, then they would have something in common. You just get frustrated and leave. I understand.
I have to pee.
Oh! X plus 2. You're supposed to ask for permission.
Can I have love?
No, sit down. X plus 2 and x minus 4 is nothing in common. Now, if you have x and x to the 4th, you have x in common. Or if you have x plus 2 and x plus 2 to the 4th, then x plus 2 is in common. But these two are prime. So, what did we do before when you have two prime numbers? You just put them together. So, x plus 2 times x minus 4. How many times will x plus 2 go into this? X minus 4 times 1 is 1 times x minus 4. Now the reason that I put that 1 in front of there is this always going to be 1. So what do you have to remember to do with this coefficient right here? Put it right here and distribute it. And I'm just doing that just so you'll get in the habit of doing it. How many times will x minus 4 go into this? Times 3 is 3 times x plus 2. Now finish it. And then we'll go back to the problem that we started with. Who went and got us a biscuit? All right, what's 1 times x minus 4? So x minus 4 plus 3x plus 6 all over x plus 2 times x minus 4. Now right here, when I do this, a lot of people go turn their head and go, why did you do that? Well, I didn't do anything new. Did I do anything new? Y'all been doing it since pre-algebra. I just wrote it as one denominator. One denominator. One denominator. One denominator. So that don't hold water. You say, why are you doing it different now? I'm not doing it different. X times x, I'm writing it as x times x. I don't know what some of the other ones were, but 2 times 3, 2 times 3, I'm writing it as 2 times 3. What can I do to the top? Combine like what? Combine like terms. CLT. Whenever, what law did we use here? Whenever you use the distributive law, usually the next step will always be what? Combining like terms. 90% of the time. The other 10% is when you don't have anything that you can combine. What's 3x plus x? And what's negative 4 plus 6? How about plus 2? Yeah. X plus 2 times x minus 4. Is there anything we can do up here?
Yeah.
There's a 2 in common, right? So 2 times x plus 2 over x plus 2 times x minus 4. Miss Holly, can we cancel those x plus 2's out? Yes. So the answer is 2 over x minus 4.
Can you factor with the 2 times x plus 1?
You're right. Oh, shoot. You should have said something. Well, I just did this to throw you off. If this was 4x plus 2 and you factored out correctly and you got 2x plus 1, you could not cancel out. But if you did get 2 that were correct, that were identical, you could cancel out. But I wanted to show you that. Now I'll do it the right way. Thank you.
It would have to be 4x plus 4.
Yeah, something like that. Thank you. That's fine. I did that for y'all's mess. 2, that'd be 2x plus 1 over x plus 2 times x minus 4. Is that what it comes out to be? Either one of these answers are correct if I did everything correctly and not have a brain bubble like I did a while ago. Okay, so let's go back to the problem at hand, and you do that. Now you can finish it. Miss Zug, what time is class over? Okay, 11 o'clock? Dang, it's almost time for class to be over. What happens to the time? Well, you have to set up that gum technology. Yeah, that's right. Alright, let me go ahead and call the roll so y'all can run out of here like a bat out of Hades. Attendance tracker. Math 110. Miss Black is not here. Miss Bronner is here. Miss Carey, did you make it? She's sick. Miss Clayton, I saw you earlier. There she is. Mr. Cleveland.
Here.
Mr. Craig.
Here.
Miss Fitzsimmons. Miss Frialdi. I'm sorry. Aaron. Mr. Frialdi is here. Mr. Guffey.
Here.
Miss Geimer.
Yes.
Miss Holiday is here. Mr. Mickle. Mr. Ritchie is here. Mr. Ryder.
Here.
Mr. Savacool is here. Mr. Smith.
Here.
Miss Stoltzfus. Vaughn. Vining.
Here.
And Miss Zug is here. Alright, let's finish this problem right quick. And get out of this. Alright, so I'm going to try to hurry it up here. And out of this. No. Just there. Alright, I'm going to kind of speed up. So we're going to get x minus 6 times x plus 3 will go in there, x minus 6 times, plus x plus 9 times x minus 6 will go in x plus 3 over x plus 3 times x minus 6. Is that what y'all got? And then we use our FOIL method here, or our shortcut. This is x minus 6 quantity squared, which is x squared minus 2 times 6 is 12x plus what, 36? 36 plus, use your FOIL method here, x squared plus 12x plus 27 over common denominator. I use a squiggle sometimes, so I don't have to write all that. What's x squared plus x squared? 2x squared, Hubert. Thank you, class. Negative 12x plus 12x does what? And 36 plus 27, yeah. Is it positive? Over the common denominator. And I don't see anything coming out of that because 63 is not a perfect square, 2x is not a perfect square, and there's not a sum of two squares. You can't factor out a 2 unless you want a fraction, so that's probably your answer. Let's check it so that way you can feel good about yourself. And then I will tell you what you need to work on because everybody seems like they're working on everything good. Wow. 2x squared, I have no idea why they did that. I have no idea. We will have to look at that. I'll have to look at it. We'll look at it next time. What you need to be working on, you need to be working on the review as well as the next, be reading up on the next unit. Wednesday we'll be going over more questions. I'm going to spend time on this review because a lot of you haven't had 102.
Some of you had 102 last semester and didn't remember anything I said. So